Okay, short video lesson on how square expressions change in value and give us valley-shaped graphs. So when I say square expressions, I could say quadratic expressions. So we talk about quadratic expressions and then, if you like, quadratic graphs. Okay, so the simplest square expression of all is x squared, and the value of this expression will change as x changes. So x squared means take x and multiply it by itself. So if you take 0 and take 0 and multiply it by itself, 0 times 0 is 0. If you take 1 and you square it, you get 1. 1 times 1 is 1. If you take 2 and you square it, 2 times 2 is 4. If you take 3 and you square it, you get 3 times 3 is 9. If you take 4 and you square it, 4 times 4 is 16, and so on. Remember that if you take negative 1 and you square it, negative 1 times negative 1 is positive 1. Negative 2 and you square it, negative 2 times negative 2 is positive 4, because a negative times a negative is a positive result. So what we have here is the value of this expression changes. It has a low point, its lowest value is 0, but then it's symmetrical either side of that. It goes up this way and up this way, 1, 1, 4, 4, 9, 9, 16, 16, and so on. The increases each time, so it increases by 1, by 3, by 5, by 7, by 9. So the increases are not steady, so this will not produce a straight line graph. What we can also see is that it will be symmetrical. So the graph we're going to get will not be a straight line, it will be a curve, and it will be symmetrical and will look something like this. So the lowest point of the curve, the lowest value that the expression ever has is 0 here. And then it goes like 1, 4, 9, 16, 25, 1, 4, 9, 16, 25. Symmetrical, perfectly symmetrical, about a center line, a line of symmetry running down here. So on this slide here, you'll see the values plotted on a proper graph. So the values go 0, the values of the expression go 0, 1, 4, 9, 16, 25, 1, 4, 9, 16, 25. Now we're going to look at two other slightly more complicated expressions, x squared plus 4, x squared add 4, and x squared subtract 4. These will be the same as these ones, but for this one there'll be 4 added each time to each of these values, and for this one 4 subtracted. So if x squared is 25, if it's x squared add 4, 25 add 4 is 29, 16 add 4, add 4, add 4, add 4, and so on. For this expression here, subtract 4, subtract 4, subtract 4, and so on. So the lines and the values of this expression will be similar, but it'll be 4 greater in each case. Here the low point was 0, so this case the low point will be 4. Here the low point was 0, here in this case it'll be negative 4. So the curves will be the same shape, they increase in the same way, but they'll have a different low point each time. This will be 4, not 0, but 4, not 0, but negative 4. So the graphs look like this. The one in the middle is the original one, the graph of showing how x squared varies. This one up here, the higher one, is showing how x squared add 4 fluctuates. And the lower one, lowest of the three, shows how x squared subtract 4, how that varies. So we've got 3 square graphs or quadratic graphs showing how this expression, and this expression vary. Now we've got a more complicated expression. We've got the expression x squared add 6x add 9. To understand how to work out the value of this expression, I recommend that you watch either watch the video lesson on the 6 operations or the one about expressions. My recommendation would be that you use an arithmetic tree to work out the value of this. You must do the squaring first, then you do 6 lots of x second, so you do the powering first, then you do the multiply, then you have 2 additions to do, so you do this addition first, then this one. This will give you these values here. So the values of this expression change. They, like all square or quadratic expressions, the values go down to a low point and then up again. So, and they're not equal steps. So again, we'll create this kind of a shape. The low point here is 0, then it goes 1, 4, 9, 16, 25. This time though, the low point is not at 0. The low point of this curve, the low point, will occur when x is negative 3. It will still be the same shape, but for x squared, the low point was when x is 0. For this one, the low point occurs when x is negative 3. So the curve will move over to the left. So here are the three curves we had before. That was the graph showing how x squared changes in value. And this one here, this is the new one. This shows how x squared plus 6x plus 9 changes in value. The low point is the lowest value of the expression is 0. So it goes 0, 1, 4, 9, no, sorry, 1, 1, 4, 9, 16, 25. It's exactly the same shape, but it's moved. It's no longer bottoms out there. It now bottoms out at this point here. Okay, when x is -3. There are two other expressions we're going to have a look at. This one here and this one here. This one is the same as this one, but for the fact that the 9 increases to 13, so it's an increase of 4. This one here is the same as this one, but for the fact that the 9 has decreased by 4. So the values of these two additional new expressions will be, in this case, there'll be 4 more, 4 more, 4 more, 4 more. In this case, 4 less. So 4 less, 4 less, 4 less. So I haven't drawn the two new curves in, but I can show you what would where they would be. If I draw them in, the graph would be very confusing. So there's the x squared plus 6x plus 9 that's sitting there. That's roughly in the right place. X squared plus 6x plus 13 will be 4 units higher. So it'll sit approximately there. So moving up 4 units, it'll take it from there up to about there. And the last one, x squared plus 6x plus 5, will be 4 units lower, 4 units down. The low point is -4. So that's that one. Then going down 4 units, that's where x squared plus 6x plus 5 will sit. So hopefully that gives you an idea of what to expect when you're plotting the graph to show how a square expression or quadratic expression changes in value. So we would call these, people quite often call them quadratic graphs. Always a valley shape, although the valley can sometimes be upside down, I'm not going into that now, and become a hill, but it'll always be a valley or possibly a hill shape, and it'll always be perfectly symmetrical, and it'll have a sort of line of symmetry running through the low point. So the line of symmetry here is the line x equals -3. And that will do for now. Thank you.